Hello guys, welcome to Considerations in Writing a Modern Data Engineering Framework. We are going to be talking about how do you actually write an actual software engineering focused data engineering framework, which is a really cool topic, but there are not that many written frameworks nowadays, and we'll hopefully show you something cool today. My colleague here is he's Aimilios. He loves challenging problems, and he's currently working as a software engineer in Frontiers. We'll talk a little bit about more about Frontiers in the next slides, but Frontiers is one of the biggest open science publishers in the world. So if you want to publish a paper, usually want to publish in a journal, make some peer review, that's the company, and I met him there. Because I used to work in Frontiers as well.
So, good afternoon from my side also. And my name is Aimilios, as Ivan told you, and I will present you Ivan. Ivan right now works with CreateDB, which is an open source distributed database, and they have different workloads that you can work with the database. We used to work together as software engineers for Frontiers. He likes, in general, software, and he's contributor to many open source projects. And in terms of outdoor activities, he tries to do some hiking from time to time.
So, if you allow me 1 second, we're going to be talking about a piece of software that we wrote in open source ourselves. So, this is something this is not sponsored by any company. This is just pure open source done by us in our free time. So if, I want this to be more casual, if you don't mind. So if at any point you've got any question at all, just raise your hand, because, this is just some community thing where we just wrote something and we want to tell you how we did it, why we did it, and hopefully you will enjoy.
Yes, and we wanted to give you, the full picture. So if you want to give somebody the full picture, we could have thrown you 200-300 lines of code, go line by line, but we try to explain you what problem did we have and what solutions we went through until we arrived to what we will show you. So I will talk a bit about Frontiers, although Ivan made a good introduction. Frontiers is one of the largest research publishers. We publish research papers in our journals, and to do that, what do we need? The problem. The problem is that we need to find the right people. I mean, you can't review something, you can't review a paper if you don't have the specific knowledge in the specific field. So what we have? We have many journals because we receive many papers that need reviewing. Although from these papers, I think that most of you have read one. You will see that we have the researchers before the abstract, and sometimes the researchers, they change institution, they cut the first name, they use only an abbreviation. Sometimes they get married. So it's difficult, to know if you are the person, if the person that you are looking at is the person that you have in front of you. And don't forget also that you may have people with the same name. So how do you know which person is? Of course, this is another problem. We won't talk about it. It's a problem which is called entity disambiguation. It's not solved by a data engineering framework. It's solved with other ways. What we do not have to find the right people is a universal researcher database. So we have Google Scholar, we have publishers which maintain, like Frontiers, its own database of researchers, but we don't have a universal database, and that is a problem. How we try to solve the problem? We try to solve it by gathering data. I mean, it's the only thing that you can do. I try to gather as much data as I can, so to solve my problem. But this opens, you solve one problem, but you face the next challenge. And this is, okay, I gather data from everywhere. This means that I have diverse data sources, which can be databases, your own or external public data sets, blob storages in the cloud, FTP servers, you crawl data. All this data needs to go through different versions, different environments, because there is a standard development process, so at least you need to have specific steps that you say that this data is until this point. And the other thing that we do for sure is we create a data model, because having data just crawled or stored somewhere doesn't say anything. You have to match it somehow. You have to make some relations with it. And on this data, you perform transformations, because if you gather it from different sources, of course, it won't be the same format. It won't be the same data as exactly you want it. So you need to specify something that is good for you. And these are the transformations that we perform. We start with cleaning most of the times, and then we do the transformations that we need until we arrive at the stage that we say that this is the production data that other teams can use. Besides that, when you have data, you need to test this data. So you need validations on the data to see that everything has gone correctly through your transformations. And on top of that, something that most people ignore, and they say, okay, I have a good software, I can do everything with it, is that you have the infrastructure behind it, how it works, where it runs. So you need to monitor all this, and you need to orchestrate all of these jobs so you get the final product.
If you will, I'm curious, do we have any data engineer in the room? Okay, that's cool, because this is like a really data engineering problem. Like, you want to have as much data as possible, and just the very situation of handling so much data, having the data stored in so many different places, you end up with S3, with Azure, blob storages, with FTPs, databases. Handling all of that and transforming data from one place to another is an extremely challenging problem, and not only in the logistic way, but also the more data you have. We're not talking about gigabytes, we're talking about petabytes of data. In the overall complexity increases a lot. So one common solution for every company is to get as much data as you can, but that as Aimilios said, it opens a Pandora box, and that's a really interesting problem.
So as Ivan explained you, okay, we have data, we have acquired as much data as we can, but how do we keep track of all of this? And we move to solutions. So we will tell you what we did in Frontiers. The first solution was, let's say, an investigation, a prototype. When you start with an idea, sometimes you assume, okay, this is the best I can do, or you think that this is the best that can be done. Usually it's not this way. You go through iterations and iterations, and every iteration has something to improve. So what happened in the first solution is that for data, we were using public data sets, and for processing, transformation, and let's say orchestrating the whole thing, we're using Azure Data Factory plus some USQL scripts. So this solution was good, but it had problems. And let's see what kind of problems we had. Of course, there was low confidence, because as with everything, when you start, every start is difficult. So we had low confidence on it, we were new to it, and the system was prone to break. The second thing is that the majority, if everything is a bit too much, the majority of the things were hard-coded. And this is difficult when you want to go through major changes. The third thing is that we had to manually intervene, and we had zero monitoring of what is happening. So this is a problem, because we had to be there all the time to do something, to fix something. Sometimes, you need some things to run by themselves. And the last thing is that we had one release of the product every couple of months, which means that, okay, we couldn't give a very good or a very new product to the rest of the company. So we had to improvise and improve, and we go to the second solution, which is again something, a data engineering framework that we wrote. As you see, if we want to show you some sample code, you will see that we have some sample model, which you see that it inherits, it injects itself by some S3 model, which means that if I have, because if you use terabytes of or petabytes of data, we cannot be talking about local storage, of course. So we are talking about cloud solutions, either if it's one cloud or multi-cloud, that's not a big deal. But you use cloud storage. So we needed the first entity, and with the introduction of classes in our solution, was the storage models. And each model, each data entity, for example, let's say that we have authors, then was injected the storage model. And of course, this would create, the schema and everything else for the entity. Ivan, do you want to add anything? Perfect. And then we have the open source solution, and we want to show you what kind of differences we have. From Ira Knowledge, which is our own data engineering framework, it's closed source. It's something that we use for the company. It is based on PySpark, so we use the Spark engine, and we run it through Databricks. So we use notebooks, and we run it through Databricks. On the other hand, Datasaurus, which is the open source solution we have introduced, as we say, it's open source. So we contribute, you can contribute, we accept pull requests and help. It is using another compute engine, which is Polars, and we say that it is vendor agnostic. What that means is that, in theory, you can run it in your own machine, you can put it in any cloud, you can use any set of notebooks that you would like to. What we have done so far for Datasaurus. The first thing are the environments. So when we work with data, as I told you, we need to have transformations on the data that we have. So like every development life cycle follows, we have environments with different stages of data. Development, staging, production, however you want to name them. Datasaurus supports different kind of storages. So you can use your own local storage if you want to run for a small project from your machine. You can use cloud storage, and you can use databases. We try to support many different formats, the classic ones like CSV, JSON, Parquet, and more. We support models because this is the idea, and we will see later on how we have written them. We support transformation, which is a classic action that everybody is doing when working with data engineering problems. And the two upcoming things that we want to try to implement is validations on the data that we have, and data lineage. So to have the relationships between the entities that we have already defined for our project. And now it's time to take a look at what we have written.
Yeah, so I want to step back actually and ask, do any of you in the room know what PySpark is? This thing here. Any hand? No one, okay. Do anyone know?
No, we had one hand.
Who? You know, raise it. I want to see it. All right, there is one guy who knows what PySpark is. Do anyone knows what Databricks is? He knows it because you also as well. All right, so to give you a little bit of context, PySpark is something, you put some data in, you want to do queries, you want to do transformations, you want to do some analytics, and you split that work into different nodes, right? It's distributed computing is like the data engineering kind of core nowadays. It's very useful if you have a lot of data, but nowadays there is a new alternative to pandas as well, called polars. Do we have anyone who knows what pandas is? Okay, the PySpark guys, they know everything. Do we have any Python programmers? Python, Java? Okay, Rust? C# as well, but that guy does everything. Maybe next conference you should be here with me. Go like, all right, so the thing that we're gonna show you is written in Python, so we assume that you will sort of be able to read it, because it's also really, really simple. So just to recap, we want to move data from one place to another. We want to have a really easy control of it. We want to use polars. Do we have any web developer here as well? Again, like, you know, in the end, in my experience, I have done so many things in my career that I take a little bit of influence of everything that I've seen so far. So we spoke that we have three main things, which is storages, models, and transformations. So we're going to go step by step and explain what everything is. So for example, here we have a data storage. It will be very interesting to get a look of what we read and what we actually have. What I mean by that is that we have, as you can see, we have a class that is called data storage, but we don't have any initializers, we don't have any Python method, any fancy things. We have just some class stuff. So we are doing everything with classes. If you have done any Java with Hibernate, for example, you will see that this sometimes gets used. We are doing everything only by classes. That's a very cool thing to do, because we are not instantiating anything, we are not doing objects, we are only using Python classes as templates. And that's really cool. Like, we are not doing YAML, we are doing Python classes. And that's, you will see, it's really cool. So we have a class, data storage, a name that I came up with, and it has to inherit from storage group, which gets inherited from data source core storage. And here we can define actual storages. Like, here we have Postgres. You define Postgres storage. You also, like, all of these you import it. You pass the, you know, if you're running a SQL database, you need a username, a password, the host, where is it, the name of the database. And then in this case, we have local storage. Local storage means an actual local directory somewhere. It can be an S3, it can be something, it needs to be something that your computer has access to. We can do more, like we could have several Postgres instances, we could have several data storage, you could name it differently. Like, if you have like CI, live, production, you can just have as many as you can. But in this case, we're going to be doing stuff around local, because it's the easiest one to get access to, since we're going to be running things local, and it's on this directory in data. Oops. So in this very directory, we have one Parquet file. Does anyone know, besides the PySpark guy, what Parquet is? All right, so Parquet is just some format, some data format that it's a columnar format, but think about it like a big JSON, a big CSV. It doesn't really matter for the example. It's just some format that we use in data engineering, because it's extremely performant, because it does not store things as a row, but rather as a column. So we can use some magic things that your CPU can do with SIMD, SIMD operations, and run the operations on a column rather than a row. And that's way more efficient, because on your disk, we usually store things with that format. But anyway, coming back to the actual code that we wrote, we have one data storage, we have one Postgres, we have one local, and then we get into the profile. This is something that we call a model. A model is nothing but the schema of your data. If you're running PySpark, you've got struct fields. If you're running Django, you have the Django models. If you're running any like fast API, like any kind of data, sort of need to specify the schema of your data. You need to tell your programming language, your application, which fields to look up to. And in this case, we define them by these nice things that we call them columns. So same thing, we import the columns and we say, hey, we have a model that is called profiles. It has an ID, a username, a name, sex, an address, a mail, birthday. It has many things, right? To every column, we can give, we can specify the data type there is. In this case, well, Polars is written in Rust, even though we are running things in Python, because in Python you can pretty much run almost everything. So we specify, in this case, we specify the data type is going to be an int 64, so it uses more bytes. The default is 32, and this is a nice way of showing that we can, at any point, at the schema level, we can change from one data type to another. We could actually try to do like time, what was the name? Like we could probably try to do datetime, and it would probably fail because you cannot really convert. I mean, you can convert any timestamp into data times, but you can actually just put any data type that is not like an object, and obviously it will fail. But for this case, we just keep it as a time. And the next thing, which is the coolest thing ever for me, because I'm a nerd of software engineering, we define a class within a class. And maybe if you are new to Python, you are like, what the fuck are you doing? Yes, we can do this in Python. In Python, we can define functions within functions within functions. We can define classes within classes within classes, because in Python, everything is a class, an object, pretty much. So we do define a class that we call meta, and we define a few things. First of all, we define a storage, and this is the very same storage that we did before, right? This is the data storage. We define the table name, and we define the format. The format is kind of not really needed. It will, because the Dorosaurus is smart enough that it will try to, he will go to the data storage. It knows that it's on the local, because here we define that we are going to start the pipeline with the local. We could change it to Postgres, and it will look into Postgres. It knows that it's a local storage. It will try to look up every file in that local storage, and it will try to come up with a file format. CSV, JSON, Parquet. It will try to just try to guess. Sometimes it will miss because we will have like a bunch of defined file formats. Usually you just write the file format you want. So with this very own piece of code, we have access to a profile that has these characteristics that is found in the data storage, that has this name, that has this format. So if you're a data engineer, you don't really have to see like all these transformations, these crazy things going on. You just have to just have a very cool definition of everything that's going on. Everything is right on the screen, and it truly helps your work. Probably the PySpark guy is probably used to having these big notebooks with many different transformations, and that usually gets really hard to compute. And now we are going to define one new model that is actually computed from the model. So we just define one ID, one profile ID, because we want to have some kind of relationship, and some email just for the sake of it. And we have a special method that is called calculate data. And look at how cool it is. It gets, you just have to do profiles.df, and you get access to the data. Like it actually, the Datasaurus computes everything. It's able to find everything you defined on the meta class. And in this case, you can start doing data transformations. In this case, my data transformation is filter it. You can do profile.sex. So you actually get the column name as a part of the class. It has to be equal to F. And then we define some new ID, because we just want to have some new ID. It's just something that I wanted to do. We change the name, and that's about it. We give it a new table name and the same format. So now if we run this, let's actually see everything we did. Yeah, that's crazy. But it's because we change, here we change the data type, and it's actually giving us an error, like it actually cannot. So cool thing, like it's actually doing data type transformation. So if we define an int 8, it's like a really small, like a byte, it's gonna fail as well, because it cannot really convert from a 32 byte to an E8, but we can just do, for example, 64. You can easily do from 32 bytes to 64. You just have to fill the zeros, right? So we call this, and here we have all the data that was defined on the local storage on that very same name on that file format. So we can at any point, if we are writing a data pipeline, change from local to Postgres, and it will get the data from Postgres. The exact same thing will work for every single data storage. And that's very cool. This is the data frame, and this is a Polar's data frame. So it's somewhat different from a PySpark data frame. Now, for example, what we can do is we can get the females profile. And right now, live, it's doing the whole filtering. It's resolving all the dependencies, the storages, the file names, everything. And now we have all the female profiles. And we can see Ashley, we can see Alicia, we can see Tina. These are all made up, by the way. It's not real data that I'm showing to you. And this is really cool. And now we can start doing cool stuff. When we are doing a data pipeline, not always you want the same data to be calculated. Sometimes you just want the data to be transformed and just want to read that data all over again. So there is a method here that's called recalculate. And for example, we can say always. So every time, always. And so every time we run the data frame, it recalculates the data. But by default, it always tries to read it from the storage. So something that we can do now is we can take this female profile that we got, and we can say, hey, I want you to save this data to the data storage. I say local, but I could just write Postgres. And I want you to write it in a CSV format. So now I run this. It takes a few milliseconds, and we have the data in CSV. So I'm literally taking a big chunk of data and defining the data types, the columns, transformations, validations, and defining everything in a single Python class. And now I can write a pipeline. I can run this all the time, and I can have this move data from one storage to another. I can do from Postgres to Parquet files to CSVs to S3, from Postgres to MySQL. You can do data engineering extremely easy. And that's one of the things that solve the issue for frontiers. When you do data engineering by just like notebooks, you end up with these huge pipelines. They are really hard to maintain, and it's really hard to see like where the data is coming from, what is the schema, where is it going to, what transformations am I doing. So you sort of need to actually define things in a controlled way, and have some contract, like where am I putting the transformations? Am I just putting everywhere in some functions? No, here we do have some clear guidelines. We are an opinionated, we have our own opinion on how you should do things, and this opens a lot of doors. Some new problems that we now have in data engineering is data lineage, and that is where is the data coming from and what is it going to? And I know it seems like a really basic thing, and you are probably wondering, why is that a problem? There is a problem, because once you start transforming data, moving the data from one place to another, you sort of lose track of where everything is. Like in the end, you end up with some table. Maybe you're doing some AI, and you want to know where is this data coming from. Like, is it coming from my production database? Is it coming from my CI database? You really don't know. You really have to have a system in place. In Databricks, you can pay for that. it's extremely very expensive. But in this case, look at this. We have the data transformation in one specific place. We can read this, and I can tell you confidently that female profiles comes from profiles ID. I can be very confident about that, and we can start doing transformations, and I can read this whole method, and I can tell you where everything is coming from. So this also opens this new door. Now that we have this contract that every transformation has to be done in the calculate data method, for example, me as a framework writer, I can get this method, read it, and I can tell you, the user, where is your data coming from, where is it going to, what transformation were applied, how was the columns, how was the values for the sex, for example, it's F or M. I can tell you many things. And that's really cool, because right now in the open source community, there is not that many tools. If you look it up for polars and pretty much the whole thing, there is only one library that's called Patito. And that's pretty much the only thing there is. Also, something very cool that maybe only some Python developers might be able to say is that we are doing everything with classes. Like, this is extremely cool. I cannot emphasize this enough. Like, I'm defining things in classes within a class. I'm getting like a blueprint, and behind the scenes there is some crazy things going on, because I'm doing meta. It's what's called meta programming. I'm taking this class, I'm validating everything there is, and creating new classes, and instantiating things, and doing a lot of things behind the scenes. And yeah, this is pretty much what we have done so far. There are more things that we realistically don't really have time to, but let me see if we've got not an example. Okay, one thing that, okay, I didn't prepare it, but I can just tell you about it. We also have a class that if you give a model, you can create dummy data. So it will take every single like ID, username, name, sex. It will create the dummy data, and you can write unit tests with that. That's really cool, because sometimes when we want to write tests for software and for data, moving things around, you actually need data, but you cannot really use production data, and that's actually the best data to test things. But you cannot really use it, because you cannot use my email to test. I mean, maybe Google or Microsoft or some shady companies, they do it, but you legally shouldn't be doing it. So you have to make this data up. Now that we have a contract, I know the data types. I can just create, and I will not be able to show you. If you go to my booth, I maybe can show you later, because I have to look it up. But we've got like really cool stuff going on besides what I showed you. This thing is being developed here in GitHub. It has a really cool name, Dotosaurus. I'm very proud of that name. And for a while we stopped developing it, because I got a new job at Grade. Things were moving also in Frontiers, but we are now getting back to the development of this. And in the end, it's just a framework that allows you to easily move data around, transform from one format to another, transformation, and have everything on one file, on one class, clear and easy to read. And it's open source. I mean, it would be a shame if it was not open source and I was explaining it in an open source conference. There are some plans in the future. We want to have more databases. We want to have Azure Blob Storage, AWS S3, TCBs, more SQL, Delta tables, validations. We want to have a few more stuff, but we're going for it, slowly developing it. So if any of you is interested, we also accept contributions, issues, testing. If you obviously have any questions after the talk, you can raise an issue, anything you want. We are more than happy to help you with. okay, that's 10 minutes, but I think we are pretty much done. So I think maybe we can just go back to this. Thank you very much for listening to the talk.
Thank you.
Is there any question? There are actually 2 hands. All right.
Yeah, so congratulations for the presentation. So one quick question is, how are you going to implement the data lineage, and what are the challenges that you are facing while doing it?
Yeah, so one of the main challenges while doing data lineage is that it's sort of a challenge that you also get when you are doing, right now I'm CreateDB, so I'm getting a lot into database development, and it's surprisingly the same thing, because whenever you do a SQL query, it gets parsed, and then there is a small thing that takes everything that was like a logical, it creates a logical plan, and from that logical plan, you do some optimizations, and finally you get a final plan of what's actually going to be executed at the disk level, right? That's actually what we are seeing here. I mean, not really, because Polars also does their logical thing, the improvements, but the main challenge is that how do you, like, all right, we have everything defined here. What do you show to the user? Like, I know here that I'm filtering, I know that I'm filtering this, I know that I'm creating a new row index. It's very easy to do when you only have one transformation. But when you are mixing a lot of things, that's where it actually gets complex, because you have a lot of transformations. If you read the logical plan of Polars, it gets really long, the same way a SQL plan gets really long. One solution that we thought for that was what we call the transformation pattern. There is a pattern that not also solves this issue, but solves another issue, which is to break all the transformations into smaller pieces. And to every piece of transformation, you define a class, and you also define a schema that goes in and goes out. So it also helps you write cleaner and better long transformations, but it also shortens the actual transformation. So if you want to have data lineage, you can say, okay, so from this entity or this model or this piece of data, it goes from these very small pieces of transformation. So it's kind of easier, but then obviously you still have the challenge of how many small transformations do you show? Do you actually show one arrow from A to B? Can you actually get, sometimes if you are like creating new entities from one, how do you actually build the arrow from one to another? That's a big challenge. The data transformation pattern is already done. Like, we have already researched it and we have already done it. It's on a pull request. Actually, I just need to, I think, merge it. And from that, it's all about reading this piece of the code. In Python, we can do introspection. We can actually, like, your code that you're executing can read the code that is being executed. It's really cool. So you can take that code, and I can literally have a function that gets this as an input. So I can sort of start building like a node or a graph, and from that have some actual logical representation of what's going on. And from that, it's more of an UI issue, like what do I show the user, what do I show the library. But it's a really hard problem to solve. I mean, Derbeck solves it, but they do, every time you do a transformation, they log it, and then they look at the logins, and they kind of come up with this map, and it works sometimes. You are paying like a lot of like a lot of money, thousands of euros every month for something that sort of works. Sometimes you get a right answer, sometimes you don't. We tried it out at Frontiers a while ago. It was too expensive, and we had so complex transformation that it just didn't work out for us. So yeah, I hope that answers the question.
Thank you.
on the data transformation side, are you familiar with Apache Beam?
Yeah.
And so tell me why is your system better than like using an Apache Beam or Dataflow for the transformation side?
Yeah, so I can also answer that question in why would you use this versus PySpark as well, for example?
Yeah.
Like, honestly, that is not something that I should answer, because if you are using Datasaurus, you have already made a commitment to use Polars. And so the actual question is, why would you use PySpark? Why would you use Polars versus PySpark or Polars versus DataBeam? In the end, Polars is a better pandas, a better data frame library. So in reality, that's where the key question is. What we are doing is taking Polars and writing a framework around Polars. So we could, in Frontiers, we did the same thing with PySpark. So to answer the question, why would you use Polars versus PySpark? PySpark is a distributed computing framework, whatever. In Polars, it's something that gets executed on only one machine. But it turns out that nowadays, one machine can do a lot. Like you can solve a lot of problems with one machine. Polars has something also really cool, which is data streaming. So you can do transformation, and the streaming is being the data is being streaming live. So you can actually do transformations that are bigger than the RAM, than the memory that you have. That's huge. That's so cool. You can do a 100 gigabyte transformation on a 12 gigabyte computer. So that's one of the main things that made Polars one of the coolest data frame libraries nowadays. So is our system a substitute for Apache Beam? No, it is not. Our system, our framework is just that if you have already committed to use Polars, to use that data frame because you have data scientists, you have data engineering things going on, and you want to use Polars, you can use us. You can use this library to make your job not a nightmare, because data engineering work can get really nightmarish really quick once you have these huge notebooks, huge transformations, huge model, huge data model storages, key vaults, secrets all around the place. There is no unique way of doing anything. There is simply not. Like you can start. It's the same as web development. There is no reason why you would really use Django or FastAPI or any framework at all. You can actually just subscribe to a socket and start sending streams of data, right? But in the end, doing that it's a nightmare. You cannot really realistically do that. So you use a framework that already solves many problems for you. So that's where we actually stand. We are not really anything extremely crazy. We are just some guys that saw that working with these popular technologies is really hard and and can get really hard really easy, and we try to write a nice API around it. That's the actual idea of what we're doing. If that answers the question. Or if I think we're out of time. 2 minutes, all right. Unless there is anyone that wants, I mean, I could focus more on that, but that's pretty much the answer. Like, we are not really a competition against that. We're just some framework around this new popular technology. Right, that seems to be it. Thank you all for listening to us. We will be around the place, so if you've got any other questions, just let us know. Thank you for listening.
Thank you.